Welcome to math class today. Today we are going to be learning about histograms, which is another way of displaying data. So far we have done line plots, which is a great way to see all of the data laid out in an organized way. A histogram is a little bit different, and it's one we might use when a dot plot's not reasonable, when we have a whole lot of data and we don't want to make little X's. For all of that data, a histogram would be a great way to represent our data. And also if we have a large range of data and we don't want to make a number line that goes on and on forever. So histograms are awesome for that because we're going to group data together in what we call an interval. So let's get started. So we have two learning targets today. One is that we can display numerical data on dot plots, which we've already done, histograms and box plots, which we will do later, and that you can describe the distribution of a set of data using the center, spread, and overall shape. So we're going to also look at some histograms and be able to read those and describe how the data is spread out on those histograms. So here we go. Here is how you make a histogram. A histogram really is just a bar graph with a couple of changes. So let's look at the data, and then the first thing we need to do is decide what intervals are most appropriate to use, and the intervals need to be equal. So if this is our data right here, where we have the number of Olympic medals that the US won in the Summer Olympics, we're going to look at the range, first of all. So it looks like we go from about 55 medals all the way up to 174 medals. So that has a pretty big range of about 125 almost. And so we don't want to draw a number line that has 125 different things. So what we're going to do is we're going to group this data together. So we need to decide what the size of our groups are going to be, and we call those an interval. So because of the size of that data, I think the best intervals to use are going to be to go by 20s. So we have 51 to 70. Now notice all of my intervals are going to look the same: 71 to 90, 91 to 110. They all have to be exactly the same size. We can't have one interval of 20 and another interval of 10 or 5. Okay, so notice we have some empty intervals here. There are some that don't have any data in them, and that's okay, but we can't leave them out. We need to include them to get all the way up so our intervals are the same size and we get all the way up to the last piece of data that we need. So it's okay if you have intervals that don't have any data in them. You still need to include them. The next step is to go through your data and just do what we call a frequency table. This is a frequency table. And to just put a tally mark in each column for where that piece of data goes. So 55 would go in this column right here. So there's the tally mark for that one. 56 and 62 would also go in that section. So there's the tally mark there. And then we went through the rest of the data and put our tally marks in the section in which they belong. So our first step is to decide what our intervals are. And our next step is to make a frequency table or a tally table of how many pieces of data are in each group. Then we take that tally table to actually create our histogram. So we have our x-axis here, which is always going to be whatever it is you're counting. In this case, it was US medals. And then the y-axis is always going to be your frequency, how many pieces of data were in that category. So then each of the bars is labeled with the interval, and then you make a bar going up to the frequency of that interval. So 51 to 70 had 3 in it, so it goes to 3 right here. Now, the other thing that's different about this than a normal bar diagram is that the bars are connected to each other. In a histogram, you don't put spaces in between the bars. Now, there are spaces here because that represents these 3 intervals where there is no data, but they're still on there. We just don't have a bar of any height for those 3. So we have kind of this outlier up here where most of our data lays here or lies here. And then we have this outlier out here. So let's try one of our own. So it says the data below shows the number of winning points scored at 15 NCAA Division I Women's Basketball Championship games from 1991 to 2005. So here are those scores. So we've chosen an interval of 5, so 59 to 64. So the range was of these scores was, it looks like, about 62 all the way up to 93. So I needed to choose some intervals that would include all of those numbers. So 59 to 64 is great. You could have done 60 to 65 as well, or 60, yeah. And so actually these are intervals of 6, 59, yeah. And so then we've taken and made a tally table of each of these scores. So 84 goes in this category, there's a tally mark for 84. 70 goes in this category, so there's a tally mark there, and on. And then this column sets frequency, and that's just counting up how many tally marks are there. So this one had 1, 5, 3, 2, 2, and 2. Okay, so then we take that table and we can make our histogram. So I've labeled each of these columns down here with the interval. Notice that I have a title on my histogram of what it was I was recording, points scored in NCAA Women's Championship games. My x-axis is numbered. These represents the number of points scored, and my y-axis represents the frequency. So in the category, or in the interval of 59 to 64, there was only one score that fell into that interval. So I'm going to make my box just 1 unit high. In the 65 to 70, there are 5 scores that fall into that range. So I'm going to go up to 5 right there. Then there were 3 on the next interval, 71 to 76. So 3 right there. And then there were 2, 2, and 2 in all of the remaining intervals. So notice that my bars touch. There's no spaces, and I don't have any intervals where there was no data. So I don't have any spaces for intervals either. So I just have an entire graph that is all connected right there. And that's what my histogram representing that data would look like. It helps me see kind of where the most of the data was. This seems to be an unusually low score because there's only one. We can kind of take a look at that information, which we're going to do in just a little bit. Okay, let's try another one. So the scores on a mathematics test were, and here's a list of what those scores are. It asks us to complete the accompanying table and then use the table to construct a frequency histogram for the scores. So it looks like my Y is missing on frequency here. So I'm going to fix it. There we go. Well, let's see. There we go. All right, so here we go. Our intervals, we've chosen an interval of 10, so 40 to 49, 50 to 59, 60 to 69, and so on, because of the range went from 40 all the way up to 85. So we needed to, 10 was a good interval to use there. So I've just taken and done tally marks for each score and put that in the interval in which it belongs, and then counted up how many tally marks are in each interval. So I've labeled my graph here. These are scores on mathematics tests. Down here are the scores, and here's the frequency. I've labeled each with an interval, and I'm going to use 3 little squares for my bars. So all that is left for me to do then is to make my bars. So from 40 to 49 only had a frequency of 1. So I only go to 1. 50 to 59 only has 1. 60 to 69 has 3. So I'm going to go all the way up here to 3. And then 70 to 79 has 3. That one I didn't quite get it close enough to touch there, but it should be touching. And then the last one was 80 to 89, and it also has 3. So that's what our histogram would look like. That represents the scores on the mathematics test. All right, if you would go on to this next one right here, the following data consists of the weights in pounds of 24 high school students. And you see if you can fill out the table and then make the histogram on your own and then come back to the video and check your answer and see if you were able to do it correctly. So this is what my frequency table looked like. We had intervals of 50 here because our range was so large, so we don't have to have a whole ton of intervals. And then I had 6 in, then 7 and 6 and 5 in my different intervals. I've labeled this the weight of high school students. Down here is my weight in pounds, and up here is my frequency. So I'm going to make my bars now. So between 51 and 100, there were 6. And then the next one had 7. So there's 7, and then 6 again. And then that last one had only 5. So that is what my histogram would look like. That represents the weight of these high school students. All right, this one is slightly different because we're going to come up with our own intervals, where the other ones, the intervals were given to us. So Peter and Chris Griffin are going to a hot dog eating contest, and the following data shows how many hot dogs each of them ate in an hour. That's disgusting, and this is incredible, 90 hot dogs in an hour. Ugh. But I looked at my data, and it went from 44 hot dogs all the way up to 90 hot dogs. So we had a range of about 40. And so I thought that going by tens was probably a good range. That would give me 4 to 5 intervals. So I started with 41 and went 41 to 50. Notice we never go 40 to 50. That would be actually 11 numbers. And then if we went like 51 to 60, then that one would only be 10. So we've got to make sure that we go like either 40 to 49 or 41 to 50. And then 51 to 60, 61 to 70, 71 to 80, and 81 to 90. I've made tally marks for each of the amounts of hot dogs and then counted up how many hot dogs were in each category. I've labeled my graph. This is hot dogs eaten. And this is the number of hot dogs down here, and then the frequency. And now I just need to make my bars. So in the 41 to 50 range, there were only 2 people who ate 41 to 50 hot dogs. In the 51 to 60 range, there were 3 people who ate that. Whoops, I think I meant to do 3 of these. Okay, so there were 3 people who did that, so 1 more. There in the 61 to 70 range, that seems to be the most popular. There were actually 5 people who downed that many hot dogs. And then the 71 to 80, there were only 2 that were able to do that many. And then 81 to 90, there were actually 3. Now I'm kind of short a square here, so I'm going to go off my chart. So my boxes are the same width because I want my bars to be the same width. So there's what our histogram should look like for our hot dog eating contest. All right, you turn the video on pause and you look at this next one and do the very same thing. Come up with your own intervals and fill out the chart and then make your histogram. Make sure you label and then come back and check it with mine. So I decided to do intervals of 10 again because my range was from 50 all the way up to 99. So my range was about 50, so I decided to do intervals of 10, and that gave me 5 intervals. So I did 50 to 59, 60 to 69, 70 to 79, and so on. And then when I tallied them all up, I got 6, 2, 4, 5, and 3 over here. So I've labeled my histogram score on a math quiz. These down here represent scores, and here's my frequency. So now I'm ready to put in my bars. So the 50 to 59 range, 6 people actually scored between 50 and 59. One thing that you can't tell just by looking at a histogram is exactly what those scores were. We know because we have the data up here, but if you were just looking at an already made histogram, you wouldn't be able to tell. You would just know there were 6 people that scored in between there. Maybe they all got 59, maybe they all got 50. You wouldn't actually know. Okay, the 60 to 69 range, there were 2. 70 to 79 range, there were 4. 80 to 89, there were 5. And the 90 to 99 range, there were 3. Again, I'm going to kind of go off there so that my bars are the same. All right, so that's what our histogram should look like for that one. Okay, so I hope that you feel like you can make a histogram on your own. So again, the steps are come up with your interval and then place each of your data in the correct interval, making sure that those intervals are equal amounts, and then label your graph and put your bars in there. Make sure that those bars are touching. All right, now we're just going to analyze some histograms. We're going to look at some already made ones and see if we can tell what it's telling us, what information it's giving us. So here is one that is some height distribution. It is, here are the height in centimeters of some students, and here's the number of students who fell into that category. Now again, we can't tell exactly what the heights of the students were. We only know that they were in between this range. So it asks us, first of all, how many students are in the mathematics class. So we need to look at how many students are in each interval and add them together. So we have 3 here and 6 here, that's 9. We have 11 more there, that's 20. We have 4 here, that's 24. And then we have 2 here, which makes 26. So there were 26 students in that class. How many students were between 170 and 180? So that's this interval right here. So we just need to look at the height of the bar, and it is at 11. So 11 students fell into that range of heights. How many students were between 151 and 170? That's these two intervals together. So there were 3 here and 6 here. So there were 9 students altogether that fell into those 2 categories. Pretty easy, I hope. Okay, some supermarket spending. A histogram that represents dollars spent at the supermarket and how many shoppers spent between that amount of money. So based on this histogram, how many people were surveyed? So let's take a look. There were 8 here and 15 here. That makes 23. And 13 here makes 36. There were 9 here, makes 45. And there were 5 here, makes 50. So it looks like there were 50 shoppers that were surveyed, or 50 people that were surveyed. Okay, the next question, what's the greatest amount of money any customer spent? Well, we don't know exact amounts of money, but because 99 is the biggest number on my graph, that's the greatest amount any shopper could have spent. I don't know if anybody actually spent $99. Maybe they spent 80, 84, 85, I don't know, but they could not have spent more than $99 because that's not on my graph. Which interval represents the greatest number of customers? All you need to do is look at the one that is the highest. So the interval of 20 to 39 represents the highest number. And how many customers spent less than $60? So I look and find here's my interval of 60 to 79. So all these customers in these 3 intervals spent less than $60. So there's 13 and 15, which is 28, and 8, which makes 36. So 36 of the customers spent less than $60. All right, which one of these histograms represents the data in the table below? So I want to find out which one matches the information in our table here. So the interval of 4 to 8 has a frequency of 8. So I'm going to take a look and see if I can rule anything out. So A, the interval of 4 to 8, has the frequency at 5. Well, that's not right. So it's not that one. B, the interval of 4 to 8 has a frequency of 5, not 8. So it can't be that one either. And C, the interval of 4 to 8 has a frequency of 7, not 8. So it can't be that one either. So I hope when I get to D, I find that it matches up. So the interval of 4 to 8 has 8. 9 to 13 is 3. 14 to 18 is 10. And 19 to 23 is 5. So D would be my correct answer. Okay, the histogram below shows the gallons of gas drivers purchased each week. So notice that this one doesn't have actually intervals. It says 5 and then 10 right here. So you have to realize that 10 starts the next interval, that this interval is 5 to 9.99999, anything that's less than 10. And then 10 would start the next interval because 10 can't be in both of them. Otherwise, you would be counting the tens twice in two different intervals. Same thing here. This one goes from 10 to 14.9999999, anything just below 15. So most drivers purchased gas between blank and blank gallons. So I'm looking for what's my tallest bar here, and that's my 15 to 20 gallons. So most was between 15 and 20 gallons. How many drivers purchased between 10 and 15 gallons? So between 10 and 15 right here, I look at the height, and that corresponds with 2 drivers. So 2 drivers purchased between 10 and 15 gallons. How many drivers are represented in the histogram? So I'm going to count up each bar, the number of drivers that each bar represents, and find out. So I have 4 and 2, which is 6, plus another 6 right here is 12, plus 4 right here is 16, plus 5 right there is 21. So this represents 21 drivers. If a driver purchased 15 gallons of gas, which bar would they be added to? So remember that 15 starts this third bar right here. So they would be added to the bar that is 15 to 20, or 15 to 19.9999999. All right, would you go ahead and try this one on your own? Put it on pause and see if you can interpret this information all on your own. And then come back and check. Okay, this histogram shows the student scores for a quiz. So most students scored between blank and blank. So I'm looking at which bar is the highest, and it's that 90 to 99 bar. So as a teacher, I would be really excited about that I had more students score there than anywhere else. How many students scored between 60 and 69? So I'm finding that interval right there, and then I'm seeing how many students are represented by that, and it is 5. So 5 students scored in that range. How many students are represented in the histogram? So we need to go and add up all of the bars all together. So 3 and 5 is 8, plus 2 more is 10, plus 3 is 13, plus another 7 is 20. So 20 students are represented on this histogram. If a student scored 89, which bar would they be added to? 89 would fall into this interval right there. So they would be added to the 80 to 89 bar. I hope you're thinking, God, this is really easy. All right, try this one on your own. Put it on pause, you try, and then come back and see if your answer matches mine. A city planner counted the number of floors per building in the downtown area. how many buildings are there in all? So I'm just adding up the total number of buildings. So I have 14 4 times, which is going to be 56. And then I have 2 more down here, 58. And 8 here makes 66. And 4 more here makes 70. So there are 70 buildings in the downtown area, I guess. And so they are all represented on that histogram right there. Okay, pause it and try this one and then see if your answer matches. Mark, a journalism student, counted the number of pages in several major magazines. Are there more magazines that had 21 to 40 pages or magazines that had 101 to 120 pages? So here's the 21 to 40 pages. It looks like there are 40 magazines that had between that number of pages. And the 101 to 120, there are only 25 magazines. So I would say that there are more magazines that have 21 to 40 pages. I would say that's my answer. And then this down here says, how many more? Well, 40 magazines had this and 25 magazines had that. So 40 minus 25 is 15. So 15 more magazines had between 21 and 40 pages than 101 to 120. All right, you are ready to make histograms and to read and interpret them. So good luck.